Hey, good evening, everybody, and welcome to yet another DC iOS meetup. Little bit of a change of our usual topics. We actually get to delve into security and talk about some fun security and cert pinning and network connections, which actually used to be part of my background. And it's kind of cool that we get to talk about it a little more tonight, which is off our beaten path. So before we get started, just a quick welcome to everybody. A little bit of a small group tonight, but hopefully this will be a good talk. And with that, oh, actually, I left that slide in from last time. We did not have an Apple event this month, but they did do an offline release of new computers and stuff. So, maybe someone's picking up a new MacBook Air or another new computer. So they did have a new release. They just decided they could just tell us over new. And with that, I'll hand it over to Dr. J.
Of course.
Yeah.
It's not loaded.
Yeah. Oh, please.
Let me switch from Wi-Fi to cell, see if that. Sure, but I don't have a personal laptop, so I realized this was my only option.
No technical presentation is complete without technical problems.
I know.
Recording in progress.
How many highly paid professionals do you need to operate?
Yeah.
Let me share.
Yeah, why don't you share? You should be co-host now.
Still saying only the host can share.
I made those two Tambolis. I made the wrong one co-host.
It crashed and
This feels like a scam.
Yeah.
Where's the other one?
here's your money back.
Yeah.
Security, sure, he's the one who's supposed to be back.
So yeah, the topic I'm going to be talking about is how to secure network connections without using certificate thinning. My name's Jay Tamboli. I work here at Capital One. I've been here for about 10 years. Here's what I'm going to talk about tonight. So to start out, I'm going to talk about HTTPS, some of the checks that are performed as part of that, and what some of the weaknesses are, why you would want to do something beyond standard checks that say web browser performs, ways to take advantage of mobile apps and how they can do a little bit more than web browser. Specifically, I'm going to talk about certificate pinning, which used to be kind of the way that you would perform better security than what standard TLS checks would give you, and why that doesn't work anymore. Then some options for security now. To start out, I wanted to, it's sharing it with my picture on there too, isn't it? There we go. When people think about HTTPS, TLS, usually they think about the encryption part of that, confidentiality, protecting your traffic from eavesdropping or interception, things like that. But a big part of it is also authentication, making sure that you are talking to, your app is talking to who you think you're talking to. And that's been part of the TLS standards since the beginning. And it's really necessary because if you don't have a way of knowing who you're talking to, then you could be talking to a machine in the middle. You could be talking to somebody who's in between you and your intended destination, decrypting your traffic and then re-encrypting it for the final destination. So authentication is really a big part of this too. And that's really what I'm going to be focusing on, is making sure you're talking to. When iOS makes a connection to a server, there are 150 root certificates bundled with iOS, macOS, Vision OS, etc., that are used. Those are the trusted certificate authorities that Apple has set up. And so when your browser says you're talking to Apple computer or Apple Incorporated, or I'm not sure what their legal name is anymore, but if you go to apple.com, it says you're talking to Apple. You're effectively delegating that authentication to the certificate authority that has issued the certificate. That's how you can trust who you're talking to. And the way that you know that the certificate authority has really vouched for that and that all that stuff works is through a trust chain using digital signatures. So when browser or an app connects to say apple.com, server sends back the certificate for that server specifically. We usually call that the leaf certificate, and any intermediate certificates that are necessary for creating this trust chain. The leaf certificate is signed by the intermediate certificate. You may have more than one intermediate certificate, and there's a signature on that. And then finally, there's a signature from a root certificate, which has to be one of those 150 ones that I mentioned on the previous slide. And so once you have that chain of signatures, you can verify those. It can't be forged, and you have a way of tracing the leaf certificate you've received back to the certificate authority that you trust. And that's how we know that it's a valid cert. When a certificate is issued, the kinds of authentication that it provides, there are a few different levels. There's a domain validation, which means just that the certificate authority has checked to make sure that the person receiving the certificate, the person who's asking for the certificate, that they own that domain. So if I wanted to get a certificate for jtamboli.com, and I don't really care anything else about the details, I just want a cert I can use on jtamboli.com, I can get a domain validation certificate. A little bit more expensive and a little bit harder to get. There's an organization validation certificate, which they, whoever I'm getting the certificate for, they actually verify that my legal name is what I say it is, that, I've got a physical address, that I am a real person, in addition to the domain checks. And then there's extended validation certificates, and these are the ones that used to, we used to see with the green bars that, I don't know if anybody still does that, but it was yet another level of validation to make sure that you really are who you say you are. So then the question becomes like, what could go wrong with these kind of validations? How could somebody who's not supposed to get one of these certificates that says apple.com, how could they get an apple.com certificate? And there are a few major threats that have actually been used in the past. One most people probably think of is compromise of the certificate authority. They could get hacked, they could get tricked, somebody could pay somebody off, that kind of stuff. And if somebody gets a certificate that way, if it's issued by a valid certificate authority, and it would be trusted by apps or web browsers that receive it. And there have been some instances of this happening. A lot of times it is fatal to the certificate authority, like they go out of business after this, because basically everybody says, we can't trust you anymore. Once you're out of that 150 set, you're a nobody. Other ways people can kind of get these misissued certificates is by manipulating DNS or BGP routing, so you can make it look like you own a domain name, even if you don't. I have a note here that there is actually a DNS record called CAA, or Certificate Authority Authorization, that allows me to, say ahead of time, I only want certificates to be issued from this specific CA for my domain. So for example, I'm going to be using apple.com as an example in a lot of the stuff here, but Apple has a CAA record that says that their certificates are actually issued by Apple's internal intermediate certs, which trace back up to DigiCert. So if I were to go to, say, GoDaddy and try to buy a certificate for apple.com, first thing they're going to check is they're going to say, okay, does apple.com have a CAA record? They do. That record says DigiCert is the only one who's authorized to issue those certs. So GoDaddy is going to tell me to pound sand. And that is a little bit weird because it's against their interests, right? You're asking them to refuse to do business, but it's there. I have some examples here actually of when times when BGP routing and DNS have been manipulated to get invalid certs. Interestingly, these were all cryptocurrency exchanges. I was searching for examples that like the big target that a lot of stuff's gone for. So that's there. And then certificate transparency, which I'll get into a lot more detail on. Really only works if people are monitoring the certificate transparency logs. And if nobody's monitoring those, then you could miss a certificate being issued for your domains. But I will get into that a little bit more later, but I wanted to call it out. So getting back to mobile apps, when you have a web browser and you're trying to make something that connects to every possible site, it really isn't customized for the things you're going to be connecting to. That's why you have the 150 root CAs that iOS has. When you have a mobile app, you generally know who you're going to be connecting to. So you can do a little bit more. I'll get into what that, what that actually enables, but just kind of set the baseline. You've got a secure distribution channel, like downloading an app through the App Store. You can customize it for what you're going to be connected to. And you can use that to step up from the basic checks. I did note down here, I looked up, Google Chrome actually does embed some of the certificates that they use inside, or like Google embeds those certificates inside Google Chrome so that when you download Google Chrome, it's already got some of the certs to do some higher level checks for Google services. So they're kind of taking advantage of the fact that they are a big browser. As far as I can tell, Safari doesn't do this for Apple, but they may. It's just, it's not open source, wasn't as easy to check. So and then I want to emphasize that when you step up the security in your app, you want to augment rather than replacing the standard TLS checks. There's a lot of stuff in there that you might not think about. I mean, we know things like you're going to check, make sure the certificate matches the name of the server you're connecting to. You want to check to make sure it's not expired, things like that. But there are a lot of checks that happen. And so rather than replacing the checks, to leave app transport security turned on, and when you implement the URL session delegate methods to do your own checks, if your checks pass, calls a callback with form default handling rather than user control, so that it still does the rest of the checks. On the mobile app side, there is an additional risk, though, that we have to deal with, and that is device management profiles. People who work for big corporations probably familiar with these, but it's a certificate bundle that can be installed on a device. It allows your employer to do a lot of stuff to change how connections work. Some of that includes adding certificates to those 150 trusted CAs. They can disable cert transparency checks when connections are made. They can set up VPNs, which makes it really easy to control where your traffic's routed. If you want to perform a machine in the middle attack, like this is everything you need to do it. It allows, as I said, for the corporation to completely hijack the connections, which there are good reasons for this. And so they're useful, but Apple makes it difficult to install them because they're also very powerful. And so I have a note here, like if you decide that in your app you would rather block a connection than allow it on a network that's potentially, I don't want to say insecure because it's something that the user has decided they're okay with. I'm going to talk about some ways you can do that. But most apps probably don't want to, because if the user has decided to install one of these profiles, then presumably there's a reason they want to do that. They want to inspect the traffic or block connections, something like that. So certificate pinning, getting back to the main topic. So certificate pinning was great because it was brittle. If the general idea was that when your app would connect to a server, you would have bundled with the app a copy of the certificate that the server's using. And then you could just compare what you receive from the server with what you've got stored in your app. And if they match, you're great. If they don't match, then you block the connection, something's wrong. And that's very brittle. I mean, like intentionally so. If there's a new certificate, if you get a certificate for a different server, if there's anything wrong with it, it's not going to match. And so you would block the connection. And that worked pretty well for a while because for a long time you could get certificates that would last for years, 5+ years or more. Today, the longest you can get a certificate for is 200 days, which means that every 200 days, at least, you have to do this kind of dance where you get a new certificate, you put the new certificate in your app so that it has both your old and your new. once that's out and everybody's using it, then you can change certificate your server's using and everything continues to work. Doing that every 200 days is maybe doable, but in March next year, it's going to go down, or sorry, every 400 days now. March next year goes to 200 days. 2027, it's going to go to 100 days. 2029, it's going to go down to 47 days. And these are maximums. So Let's Encrypt right now will let you get a certificate that's only valid for 6 days. And the reason for all this is that the folks, Apple, Google, et cetera, who are making web browsers, they want to have shorter lifetimes so that if a certificate's private key is compromised, there's limited usefulness. But also they notice that there are problems where companies go out of business. And, they might have a domain name where there's a certificate floating around that's valid for it, and it may be good for years and years. So if you shorten the lifetime, it means that the certificate authorities have to check more often to make sure, is this company still legit? Have they been sold? Do they still have control of their infrastructure? Stuff like that. And I think the conclusion really was that the certificate authorities who are performing those checks, they are a lot better at enforcing security, at validating this stuff than Tamboli is at keeping track of my private keys. So expire more often, I have to renew it more often, and that means that the burden is more on the certificate authorities to meet stuff. Is still good. The other thing that's changed since TLS really rolled out is that more and more third-party integrations and CDNs. And so those can be certificates that are outside of your control, and you don't really notice until things break. We have these maximum lifetimes. Certificates have expiration dates, but people may decide to rotate them before they're expired just to be proactive, or they may have other deadlines. Who knows? So both of these mean that it's really not possible to keep up with leaf certificate pinning. There was actually an HTTP header that was kind of short-lived that set up cert pinning. The RFC was published in 2015. It was added to Google Chrome and Opera, and Firefox, and then just a couple of years later, they deprecated it and started removing it because things would break, servers would rotate their certs, and the connections would stop working because those servers had said pin to this cert, and then they changed it. And so it's not a good solution. So what can we do that's better? The main replacement for these kinds of security, and really just a step up in security in general, is this framework called certificate transparency. And certificate transparency, the idea was that it might not be easy to stop a malicious certificate authority from issuing a certificate they're not supposed to. But with certificate of transparency, at least we can know it happened and we can react appropriately. The way this works is that when a certificate authority is about to issue a new certificate, they send that free certificate to a handful of certificate transparency logs. These are public logs, are operated by other companies. A lot of them are operated by other certificate authorities or web browser companies. Those log operators then send back a digital signature that can be embedded in the certificate when it finally gets issued. And those log operators that publish those certificates, they do it with an append-only log. There's all kinds of fun cryptographic stuff to make sure that these can't be changed once they've been published. And it serves as kind of a public ledger of all the certificates that have been issued. And the idea is that I may not be able to stop some small certificate authority in the Philippines from issuing a certificate for jtamboli.com, but at least if they do it, I will know about it, and I can try to get them to revoke it. I can try to get them to not do it again. It'll expire eventually. It lets me actually do something about it. Whereas before certificate transparency, that might be out there and I might never know what's happening until somebody gets compromised. Yeah.
This whole process where you keep the timestamps along with your cert, is that also called stapling? Or is that something else?
No, OCSP stapling. I didn't write this in the presentation. Is it the revocation list?
Yeah, it's a revocation protocol.
Yeah, so when I find out that there's a bad certificate issued, there are a few different ways that I can get that bad certificate to stop being accepted. There are certificate revocation lists, which are like, it's just a big list of certificates that shouldn't be accepted. They use a ton of bandwidth and they don't work very well. There's OCSP stapling, which is a way of my server, like kind of, again, publicizing that a certificate shouldn't be accepted. Going back to the shorter lifetimes, that stuff doesn't really work that well because you've got a bad certificate out there, then you're trying to get out where that bad certificate shouldn't be accepted. Like it doesn't really stop the bad certificate. It just kind of keeps honest people honest kind of thing. Like it's not really that great. So the shorter lifetimes is really the way to limit that. It is, actually, I should note the signed certificate timestamps, the SCTs, those are normally included in the certificate. Those can be delivered through as part of the TLS handshake when a connection is made to a server. But from what I've been find, that's very, very rarely used. Putting them inside the certificate. It was designed that way so that if you got a certificate and it had signatures from, say, 3 CT logs, and one of those logs got shut down, and you didn't want to get a new certificate, you could get another SCT and deliver it through another way. But as a practical matter, if that happens, people just get a new certificate, and then that, with new logs. So that is kind of involved, but the key to cert transparency, though, is the monitoring. Somebody has to be monitoring to look for certificates for jtamboli.com or apple.com, whatever. It's a public record, and like that is really the whole strength of the system. So I see that there's a bad cert issued. Then once I do that, I can do some things about it. I can maybe modify my app to look for certain certs and refuse connections. I can ask for it to be revoked, etc. As an app developer, what you can do is you can look for those signed certificate timestamps in the certificates. And this is a check that the web browsers are doing. It's a check that iOS does, but because of the management profiles issue, if your app does it too, then that is a way to make sure that the certificate has been issued in a way to be publicly noticed. Yeah.
So what you're saying is URL session does those checks.
Yeah.
But with management profiles, that can be bypassed. So
Exactly.
you do it at the application code level, ensures that no matter what configuration they have on their device, you can at least keep things as secure as you want.
Yeah. So the management profile, like, to repeat what you said, 'cause I guess the microphones in here are pretty good, but basically, yeah, iOS URL session does the SCT validation for you, but that can be disabled through a management profile. So talking about the app doing it itself. And I will get into more detail on what you're to do that. It is also possible for an app to actually connect to the CT logs and look for your certificate in there, but as a practical matter, those logs don't have a good API for that kind of thing. You can't search for a certain host name. You can say, like, give me all the certs that were issued since this date, and probably don't want to be doing that. But the SCTs, I think of them as a promise that the logs or that the certificates are published in the logs. But it is a promise that is backed up by some threats by people like Google Chrome. If you don't do that, they will remove your CA certificate from the trust store, and then yeah, you're no good. So as I said, if you want to do the validation in the app, here is what you have to do it. Unfortunately, it is kind of complicated. The certificates that the server sends are encoded using a scheme called ASN.1. It has data structures for the subject of the certificate, the issuer, the public key. It has a section called extensions, and inside extensions, there is a section for the SCTs, and they're identified with this string of numbers, the OID, and then within that extension, the value itself, each SCT is encoded using a TLS encoding, which is a completely different encoding scheme. There are some third-party libraries that can help with decoding this. But right now, there's not anything built into iOS to do this. And in fact, I've seen posts in some of the Apple developer forums asking for something like that. There's a Mac OS only API, sex certificate copy values, which gets you part of the way there, but it's Mac OS only. And in the developer forums, Apple engineers usually say, oh, you shouldn't do this yourself. You should just defer to URL session, which sounds good, but again, you've got the management profiles that can bypass that. So if you do want to do it yourself, though, you get the extension, you unpack the SCT. Inside the SCT, there is an identifier for the CT log that produced that signature. And in your app, you have to have some kind of data mapping from the IDs to the public keys for those CT logs. And this is something that has to be updated. There's usually a log. A lot of the big div log operators split each year into two halves, and they have one log for like the first half of 2025, second half of 2025, first half of 2026, based on the expiration of the certificates. And so that is something that you have to update over time, but it is generally easier to update that than the certificates that we use in leaf pinning, because these are updated generally a couple times a year. So it's not that bad. So once you have that public key, you have to go back to, you have to get the pre-certificate. So that is, basically it's a certificate without the SCTs. You just remove those from the certificate you received. You hash it. You combine it with the public key of the certificate's issuer. And once you have that blob of data, you can validate the signature, the public key. And if that's verified, that means that the SCT is valid for that certificate, and that certificate was published and has been made available for public auditing. Some other techniques for kind of stepping up your security, you can check the public key in the certificate that you receive. This is a very common technique. The only downside of this is that a lot of people like to get a new public key every time they get a new certificate rather than reusing it. I was talking about some of the risks involved in long-lived certificates. One of them is if your private key is somehow leaked or obtained, your public key's got to change too. So this wouldn't help you there. But you can't, if you wanted to, this is an option, is you can include some kind of, either the public key or a version of the public key inside your app. Check that what's received matches what you expect. Something that I actually did not know until I was doing research for this presentation is that the organization field in a certificate, if it's present, that means that the certificate authority has validated it. So going back to those different kinds of validation, the domain validation versus organizational versus extended validation, if the organization field is present in there, it means that the certificate authority has checked it. And so that is something you can look for. The problem there is that if you've got, again, kind of going back to the MDM profile, if you've got somebody who's able to set up their own certificate authority, they can put whatever they want in there. So it does give you something, but kind of not a ton. In the situation where you don't have a management profile, this is a good thing to check, but it doesn't help you with that. There are some ways to check what kind of certificate it is, like whether it's again, domain validation or validation, et cetera. But it's a little bit complicated to get that data, and again, can be forged. Something that I've explored in the past also is trying to put some kind of custom data, almost like my own signature inside a certificate. But unfortunately, basically anything you put in there is public and somebody else can copy it out. So there's not really a good way to put some kind of secret data or protected data into a certificate that others can't copy. But that leads me to the next big thing that is good for improving security, which is trust anchor pinning. So don't do leaf certificate pinning, in large part because those certificates change more often. But the root and the intermediate certificates change much less frequently, on the order of 5, 10 years, maybe more. So for, again, kind of going back to the apple.com example, if it, instead of pinning the certificate for www.apple.com, you pin the DigiCert root certificate. And you want to, again, go back to augment, don't replace. You want to make sure that, the certificate you got is valid for the server you're connected to, but you can also check, make sure it comes from DigiCert. And that way, if somebody hacks GoDaddy or something like that, gets a certificate for www.apple.com, it may be otherwise valid. It may pass all the normal checks, but if your app knows that Apple's certificates come from DigiCert, you can say that's no good. Another advantage of this is that, again, apple.com, the thousands of servers, maybe millions, I don't know, but like lots, right? And if I know that they all come from DigiCert, that's only one certificate that I need to keep up with. I would cover them all. And then I just want to call out, there are some checklists and kind of guides on the web for doing cert pinning, and I talk about doing it different ways. A lot of the ones I found said don't do trust anchor pinning, but they all said don't do it because they would say things like, you want to trust certificates from DigiCert, but you don't want to trust all the certificates from DigiCert for your cert. And as if you were going to say, oh, it's DigiCert, and not bother checking for expiration or the right server name or whatever. So I thought it was a little bit odd that these guides say don't do it for this reason when it's pretty easy to do both. So, yeah. Before I talk about how to actually do this pinning, I do want to call out that something that I found surprising when I looked into this is that multiple trust chains are possible. So right now, the certificate for www.apple.com has an issue of the Apple Public EV Server RSA CA1, which if you were to look at the 150 CAs that Apple includes, the root certificate that matches that is DigiCert Global Root G2. And I have these ID numbers because certificates have serial numbers, but they're only unique for a given certificate authority. And I thought these ID numbers, which are from crt.sh, which is a great website that lets you explore certificates, and is all based off of the certificate transparency logs. Those ID numbers you can use to look up these certs. So they're unique for individual certs. So you've got the cert chain you see on the left. If you had a device that used the older DigiCert Global Root CA, which is the bottom on the right, you could also construct a chain just using two intermediate certs. And you'll notice that the root cert on the left has the same name as the intermediate cert on the right. And if you look at those two certificates, they have the same public key in them. So the thing to keep in mind here is that a certificate's issuer doesn't uniquely identify a certificate. It identifies an identity, but then that could exist in multiple certificates. And so you kind of want to watch out for this. It's a flexibility thing that allows for upgrades. But the next slide, I will talk about how that comes into play. So if you want to do this, if you want to validate or if you want to implement the trust anchor pinning, just like any of these techniques, you'd set up the URL session delegate function for URL session did receive with a completion handler. And that would give you the challenge, which has a protection space, which has a server trust. That server trust is the container for the certificates you got from the server. If you want to perform root pinning, what you do is you get that server trust and you use the set trust set anchor certificates API, which lets you provide the certificates that you want to trust, the certificates you're pinning against, the root certs, intermediate certs, whatever it is that you want to check this certificate against. When you call that function, it implicitly sets set trust set anchor certificates only to true. And what that means is that instead of using that big list of 150 certificates, it's only using the ones that you give it. And so you're saying, I trust these, and just ignore everything else you know. And so when you call set trust evaluate with error, it then checks to see the leaf cert we received, the intermediate cert or certs that we received, and the trust anchor certs that we were given in this API call. Can I make a valid chain out of that? And it'll return true or false. That tells you whether you're good or not. And again, if it does work, call performed, default handling. There's also a key you can put in your info P list, this NS pinned CA identities key, where you can put the public keys that you want to trust. So instead of using a full certificate, you put public keys in there. And again, kind of going back to the multiple trust chains, I should have said this. The reason you want to do this with this evaluation is that there may be these multiple trust chains. When you're doing leaf cert pinning, you can just grab the first certificate out of the server trust, and that's the leaf certificate. So you would think, well, I'll grab the last certificate out of the trust, and that would be the root cert. But that last certificate in the trust is the root cert that the OS is using, which may change out from under you. You don't have control over that. So when you do these steps where you're giving it your own anchors, it may not match the way that the operating system is evaluating it, but it will give you a correct evaluation of the chain. And similarly, if you're using app transport security with this info plist key, you're giving it a public key. And so it doesn't really matter whether that public key is in a root certificate or an intermediate certificate. If things change, if the public key works, then you're good. So wrapping this up, the recommendations I have is, first of all, do some thinking about whether this is worth it to you. It does inconvenience customers or users because they may be, they may have a management profile. They may be on a network that does kind of captive portal that you got to log into first. And if your app throws up some kind of can't connect error without any explanation, that could be confusing. And there is some maintenance required in this. So you got to decide, is it worth it? Or do you want to be that paranoid or not? That said, monitoring the cert transparency logs is very important. Whether you actually do evaluation in your code to check or not, monitoring those logs to make sure nobody else is getting certificates for your servers is pretty important. So there are a lot of services that do automated monitoring and alerting for this. I think some of them are free, up to a certain number of domains, things like that. If you do want to step up the security, I think the next best thing to implement is the trust anchor pinning. It's relatively easy to implement, and signatures are actually checked, can't be forged. So if there is a management profile installed on the device, that will be enough to stop the traffic from being intercepted. If you want to implement the signed certificate timestamps checks, that gives you another layer of protection. Not only would it detect if the certificate doesn't match the root cert you're expecting, but it would tell you that whatever it is that you've received, is it public or not? So the trust anchor pinning doesn't help you if your registrar gets hacked, because it's still going to be coming from your certificate authority. But if you check for the SCTs, that means that it was published in those CT logs, and it's possible for you to figure out where it came from and what's going on. So that helps with the auditability. And then I have the notes about checking the organization field validation level. Those are things you can do that give you a little bit more assurance, but they can be forged. So it's not great, but a decent upgrade. And then again, repeating, augment, don't replace, and call the completion handler with perform default handling. So getting into just some links, I did want to share one of the resources that I really liked through everything I've done with certificates is this ASN.1 JavaScript decoder. You can paste in or upload a certificate, and it will show you the full structure of it, including the parsed structure and the hex down on the right. You can see all the fields line up. And so if you're doing any work that's going to involve parsing the certificate, this kind of thing is really essential. And then I've included some links here on different information about how all this stuff works, including the OWASP cheat sheet that I said. I think has some bad advice in it, but also has a lot of good information. With that, I guess I'll ask, are there any questions? Yeah.
The obvious one. Where are you using all of this? Do you have any like hobby projects where you have to like set up certs, or do you have like some security infrastructure that you're managing?
Personally, I don't use these. And honestly, like one of the big reasons is that when something goes wrong, sometimes it's really handy to start up Charles Proxy or ProxyGen or something like that and intercept the traffic. And so, and I should say also that my personal budget, I don't have any personal apps that I'm selling to customers. So personal development, like I'm not that paranoid. It's not the only one. Yeah. I think that the way I would probably come down on it is if I were dealing with something financial, whether that's banking or cryptocurrency or anything like that, where it really pays to be paranoid, I would probably do the trust anchor pinning. And just because I've gone through the steps and understand it, the SCT validation. But for most apps, it is probably overkill. Unless there's a device management profile installed, the device is going to do pretty good checks on its own.
The Apple added the ability to just add some certs to the P list. Then see, those are public keys, not certs.
There's a couple of different formats. I think you can do the public keys. I think you can do a hash of a certificate.
Right.
But again, one of the advantages of the public key is that, especially in the case of like the root CA or intermediate, because you can't have new roots issued using the same public key. If you use the public key, you kind of get the benefit of that for free. So even if
The cross-signing migration stuff.
Yeah.
So that if you use Apple's notation, then you don't have to do any of the work around controlling specifically in code. You get the downside of management profiles can come in and.
So one of the things I wasn't able to figure out before the presentation is if I set up the info plist keys, does that overriding management profiles or not? I'm actually not sure about that. My guess would be that even with a management profile installed, if you have those keys, that it would fail if you have the keys defined. But again, that's a guess. Just because I feel like if somebody who's developing an app is that explicit
It's
about
their
it,
intent to say, hey, I only trust these. But that really gives you a lot of power,
yeah, I think the one thing that's missing again is the cert transparency, the SCTs. So you might have connections fail, but you might not have any way of tracking down where did the certificate come from. Is some CA selling certificates in my name they shouldn't be, or is it like a one-off self-signed thing? So the SCTs let you know that it is going to be public.
I'm going to read a question from the chat and rephrase it slightly. John asks, if you're at a company that started monitoring the cert transparency log, would a company want to write their own solution, or is there something out there to do that?
For monitoring the logs.
Yeah.
So from what I've read, going through a third party makes a lot more sense than writing your own, because the way that you monitor the logs is by connecting periodically and asking for everything that's been added to the logs since a certain entry level. And so you really have to retrieve a lot of stuff in order to keep up with that. There are some recent, like just in the past 6 months or so, ways of splitting those logs up and letting you kind of request arbitrary portions of it, but it's kind of unwieldy. So I think having centralized companies that are just digesting the whole thing continuously is a lot more efficient than having a bunch of people try to do it on their own. Jason?
Is it like a common attack vector for mobile apps to go through this route? I wonder how many banking, healthcare, whatever apps are actually going through this.
So on one of the earlier slides, I listed some of the cases where certificates have been misissued, and it is pretty rare. And a lot of cases of misissuance, it's actually mistakes. So like I called out, there was a certificate issued just a few months ago for 1.1.1.1 Cloudflare's DNS, and it was supposed to be a test certificate that wasn't supposed to be made public. And when companies do it, whether they're tricked or they accidentally publish a test certificate or they get hacked, whatever, it's really bad PR, at least within the security community. So it is, I'd say it's pretty rare, and like a lot of the companies, a lot of the CAs take it very seriously.
But specifically, is it a mobile problem or is it just a general web problem?
Yeah, I guess it is a problem for the web, but there's not much that web servers can do about it.
It's typically called the coffee shop attack scenario, right? You jump on some work Wi-Fi, don't know who runs it, who owns it, and they're just slurping up all the traffic. And if you don't protect yourself, then they'll just slurp up whatever's going over the wire, right?
Right.
It's more of a problem for mobile because you're more likely to be out and about and get intercepted on, back in the days when everyone would run to get on Wi-Fi because cellular was so slow. Now that's less of a thing, right? So it's a fair question. You can get man in the middle a bunch of different ways though, right? DNS tricks, network hacks, but the easiest was always like, oh, I jumped on a road hotspot, that public Wi-Fi or whatever. And
Yeah, I'm just wondering if it's like somehow more common to do mobile apps than a general web thing.
I think that, yeah, Chad's point about using mobile apps on untrusted networks is a lot more common than like laptop. But apps, I mean, and obviously you've got a web browser on your phone too. But yeah, I mean, without somebody somehow compromising certificate authority or a management profile being installed on your device, it's pretty secure. Like there are some hoops that have to be jumped through. And one of the things that ATS enforces by default is no plain HTTP connections. So that right there gives you like 98% of the security.
It's one thing with mobile is it's a lot more likely for people to install profiles for their work on their personal device, on a mobile device, than it is on their personal computer. And then sort of a malicious employer would man in the middle, their financial apps or something.
Yeah, I mean, I haven't really explored this, but it could also be an incompetent employer who sets things up wrong. And so they say, don't bother checking any certificates for google.com. And now if you get on a Wi-Fi network where they're giving you a bad certificate, that just lets, a good employer would say, okay, trust this route to CA in addition to the others. And that would let them do it. But I mean, I think you could say, just don't bother checking servers.
I don't know, you mentioned that doing all this for like hobby projects is probably overkill. I've been getting into home lab stuff recently with me and my friends, and I don't know, like the proxy software that we do like handles SSL termination, and it also takes care of getting the certs for us, and it's completely automated. So even though like all of our services are behind our VPN, our DNS records are public.
Yeah.
And then that's how we get our certs. And so we don't have to install a profile on our devices or an extra certificate authority. And so like, even though it's a hobby project, green checkmark feels good. And then getting that for free is the real incentive. Like we don't think about it at all. So
Yeah. I mean, and to be clear, like I definitely think that level is a good idea on even hobby projects. I do think something in that's good to call out though is that even if your stuff is not exposed to the public internet, if you get those certificates because of certificate transparency, whatever domain names you're using are published in CT logs, and there are definitely people who keep up with those CT logs to look for attack victims. So, you may have, at a big company or something, you may have internal servers that if you get a certificate for them, those names are now published somewhere. And somebody could try to use that as a way of getting at it.
Similar to how like OCSP became like a privacy nightmare. It's like now the CA knows everywhere that you go because your device is constantly phoning home to check, hey, is this cert valid? Is this cert valid? Performance problems. It's like benefits of security have these interesting side effects we don't always think about.
Yeah. I don't want to take up too much time, but one of the things that I found out about just a few days ago was that a lot of captive networks, discuss the context of airline Wi-Fi, way that they restrict who you're connecting to is that when you connect to certain TLS servers, part of that is telling the server the host name you think you're connecting to, and that's so that you can have multiple servers or multiple virtual servers in the same IP address. And that part of the request is not encrypted. And so it's possible for somebody in a privileged network position, the airline Wi-Fi, to see who it is you're trying to connect to. And, they decide whether to block it or not based on that. So even though it is TLS and they can't see like the full URL you're requesting or the data you send and receive, they do get the name of, you're trying to connect to.
It's the SNI, right?
Yeah.
So we're encrypted hello is a thing. It's really complicated. I don't know if it's gonna take off, but I guess you still have DNS, right?
Yeah,
There's
still
encrypted DNS, like there's, it's encryption problems all the way up and down, but yeah.
Does that matter though? I mean, I feel like that information was probably public anyways, regardless of whether you're on a captive network or not, so.
I mean, I've talked to people who are surprised to learn that even if things are encrypted, that you can see which servers you're connecting to.
Yes.
Like that is, I think, a surprise to some people.
Depends which servers you're going to.
Yeah.
If you want people to know where you're going,
Bankofamerica.com,
how dare you?
careers.bankofamerica.com.
That by heart.
No comment. Stop sharing. I guess I should have asked if there were any other questions. Feelings.
All right, thank you, Jay. Great talk.
I should have put my email address or something up there. Hold on.
All right, and to wrap up with our usual slate of announcements, as usual, if you are interested in speaking, please fill out the Google form. I've sent it out over the Meetup. I think I actually put the link into the Meetup description itself, so it is there. Subscribe to our YouTube channel. I should hopefully have this video out in a day or like in a week or two. I'm a little behind given that it's performance management season here, so I have no free time. Follow us on our LinkedIn page at Dev Community. That's where you'll get all future updates about videos and future meetups. And for those of you who are here, I have stickers. So for coming up, given that this was late this month and November is a really hectic month for me, we are just going to skip November and go into December. So if you're interested in talking, please fill out a form. Our theoretical meetup, if we get a talk, will be on December 9th, and then that will wrap up 2025. And then after that, we'll start looking forward to 2026. So with that, thank you, everybody, and I hope you have a good evening.